Welcome back. This is the last lesson of our pre-course on computer programming. Finally, we are being able to reach this goal. And during these last hours, I would like to answer some of your questions about possible questions about the exercises I gave you along all the course. So if you have any particular question about how to solve a specific exercise, you are welcome to ask them. Okay? Any question?
I got a syntax question.
Yeah.
If I want to use a program with more than one argument, can I use the scanf function with more than one parameter?
Okay, so let me repeat your question for the guys at home. Okay, so your question is, let's assume I want to use more than one parameter at the command line.
Yeah.
So I want to pass at the command line more than one parameter. Can I use the scanf function to read more than one single data type per time? Well, the answer is no. And the reason is that actually the parameter at the command line will be already split into different cells in the array argv. So basically the first parameter in the command line will be stored in the cell 1 of the vector argv, of the second parameter of the main function. The second argument will be placed in position number 2 of the array of the second parameter of the function name, and so on and so forth. So by using in this specific case, you can use exclusively. Well, scanf can be used to read one parameter per time, okay? But actually, scanf can be used to read in the general case, so not in the specific case of reading data coming from the command line. But let's assume you have a string that for some reason contains a character that you want to read, a number, a decimal number you want to read, and a floating point number that you want to read at the same time. So first of all the character, then the decimal number, and then the floating point number. In that case, you can use scanf to read all three data type at the same time by providing the correct formattation, let's say. Okay. So you will, instead of using as a second parameter quotation mark %d quotation mark, you will use quotation mark %c, saying that the first thing you want to read from the string is a character, then you will place a space, quotation mark %d, saying that the second thing you want to read from the string will be a decimal number, then space %f, saying that third things you want to read on the string will be a floating point number. Okay. But as I said before, this cannot be done to read the parameter passed at the command line, simply because those parameters are being already split by the executable itself. Okay. And so they are not on the same string. That's the point. Any other question? So is it clear? I'm asking to you that are at home. Please send me an acknowledgement if you are connected, just to let me know that I'm not talking with the wall and the full person in the classroom. And besides this, if you have any question about what we saw until now, please feel free to ask those questions. No? So you were able to solve all the exercises I gave you. This is a question, so you are assumed to. So the answer is mandatory, let's say.
I didn't do all the exercises.
You didn't do all the time. Okay, perfect. This is the right way to start the program. What about you? None of you try to solve all the exercises. Okay. Okay, great. Okay, so if this is the case and we don't have any question about what we saw until now and about the exercise I gave you, we can move to a different topic then. And during this lesson then, I will try to introduce you two useful things. The first one is bash programming. So we saw the command line can be used to execute command and interact with the system. However, from time to time it's useful to being able to automatize some kind of operation. This is due to the fact that it could be there could be cases in which you have to repeat very same operation many times. And if you try to do all these things by using the command line all the times, you may end up being having some errors because you cannot take your attention on the command line for many hours, let's say. Okay. So the best thing to do in those cases is to write a program. But I mean, while you can write a C program to handle command line, the best thing to do is to write a shell program. Okay, because the shell itself provides you the chance to program it. Okay, so in those cases in which you need to automatize some kind of operation in the system and those operations will be repeated many times. The best thing to do is to write a shell program. Let's have a look on which kind of program we can write by using the shell. Well, until now we saw the shell can be used as a command line, as we did until now. But let me write a program in the shell. Let me call it, I don't know, first. And we'll call it the first program. First shell program will be called first.sh. Okay, this is it. So this is, as usual, a really our editor. I mean, it's a standard editor. You may use any editor you want, as already stressed before. Let me go to, oh, I missed to change my screen, sorry, for you at home. Okay, here we are. So the first thing to do is to tell your shell, let's say, the shell you are using, that you are going to write a program which must be interpreted by using a specific interpreter. And the way to do it is to tell, look, once you are reading this line, if you haven't already load the interpreter that we are going to use, please do it. And to do it, you have to use this syntax. Hash, exclamation mark, being bash. This way I'm saying, if, well, bash because we are using the bash shell. If at this point you haven't yet loaded the bash shell, do it. And this line is more or less what you will find in in Python programs. In the Python programs, you usually have a line like hash, exclamation mark, and maybe something similar to user bin and Python, which is a way to say, look, if this way you haven't loaded the Python interpreter, you have to load it. Okay? So the first line in any shell, in any, let's say, shell script, in any script, is meant to say this script must be interpreted by using that interpreter. Okay? And the syntax is hash, exclamation mark, and the path to the interpreter that you have to load. In this case, we are going to write a shell script, so a shell program, and while I'm using the word script and not, from time to time I'm using the word script. Why? Because this program will be interpreted, and we are not going to compile it. Okay? So there will be a program that takes another program, in particular the bash, that will take this program and at the execution time understand what we want to do. Okay? So no compilation phase. Now, this is the very first line of our shell script, and we may use a comment. We may introduce the syntax for comments, which is hash. So the hash symbol is more or less like the / double symbol in the C programming language. So it's meant to say, look, after that symbol you are going to find a comment. Okay? So I can write this is a comment, for instance. And then we may have variables, for instance, and in this case you are not forced to declare the variable, so you can start to use the variables as soon as you want to use them. In particular, here I'm assigning a variable A, capital A, with the value 1, and I may assign another variable B with the value, I don't know, this is a value. Okay? So simple. And then what? Well, I can, of course, use any command we already seen for the command line. So all the commands we have already seen for the command lines can be used inside a shell script. In particular, I can use the command echo to print into the standard output. So echo, let me write hello world, for instance. Oh, hello world. And I don't know, this is a new line and variable, so well, let me use another echo, variable A as value. So yeah, I'm writing, so the first command echo basically is printing the standard output hello world. The second, and going to the next line, because by default the echo command print the string and then goes to the next line. The second echo is printing the variable A as value, and now I need a way to provide the value of the variable A. Well, inside the program I can use the name A to evaluate the variable itself, but of course if I place an A here, I end up in saying, look, this is the letter A, capital A, it's not the variable A. So we need a way to distinguish the letter A from the variable itself. Just like in the printf or scanf syntax, we use the percentage notation to have a placeholder for the value we want to print, and not the name of the variable we want to print. So in this case, instead of having this percentage symbol, we have the dollar symbol. Okay, so the dollar symbol is meant to say to say, look, we are going to talk about the name of the variable after that. And I mean, to avoid any confusion, you may also use bracket, meaning what is in between the bracket should be interpreted as a name of a variable. Okay? And this is it. And what about the b value, for instance, the value of the variable b, variable b as value, let me see, wrong, b. Okay, and this is it. And as you may remember, probably, any program in POSIX system should return a value, and the value is interpreted as an error code for that program. Okay, so in this case we may, it's not mandatory, but we may return a value too, and to return the value we may use, well, we must use the exit command. The exit command takes one parameter, which is the number you want to be returned by the program at the end of the execution. So by writing exit 0, I'm basically saying, let me just check whether at home you can follow me. So if at home you are following me, just send me an acknowledgement from time to time. Okay. So I was saying the exit 0 line is meant to return the value 0 at the end of the execution of the program, and this is due to the fact that any programs in POSIX system must return an error code. Let's say 0 means no error at all. It's not mandatory. If you don't write that line, by default the program returns 0. Okay. And okay, this is it. Let me just show you that we can use the hash symbol as a way to tell our interpreter that after that symbol we are using we are writing a comment. So this is a comment 2. Okay. Okay. So let me save it. And this is our first instruction. Our first shell script. Let's try to execute it. Well, Control Z, background. So I've interrupted the execution of my editor and place it in background. So now I have back my shell, and I can use the editor at the same time. So let me reset the terminal, just in a way in which you here in the classroom everyone can see what I'm writing. So if I have a look at the directory in which I'm right now, you can see first. So that is our shell script. If I have a look at it, I end up in seeing exactly what we wrote in our test. Let me try to execute it. Reset. So as we did until now, we have to write the name of the program we want to execute. So let's try to use first sh, and oh, let me change the language, sorry, so that everyone can understand what's going on here. Oh no, the opposite. Okay, so don't worry about my last command. My last command was meant simply to pass from the Italian, let's say, version of the command line to the English version. Okay, I changed my language basically. And by executing the program, I end up with an error, command not found. And can you tell me why?
Because we have to write /.
Okay, perfect. Since we are not in a standard directory, let's say one of the default directories meant to store executable and command line and the commands, okay, our program is not found by our shell. So we must provide a path for it. Okay, and the easiest way to provide the path is to write / first. Okay, so in this way we should be able to execute the program. So let's try to execute it. Error. We got a different error although. Why the previous error was command not found, meaning that the command line wasn't able to find the program. Now we are getting a permission denied error. Why? Can you guess it? Pardon?
Is it needed to be a super user?
Not really. So someone in the classroom is saying probably you need to be a super user, but this is not the case. Just let's try to be a super user. My password. So I am using this sudo command, which is meant to impersonate, let's say, the super user, and I'm using the password. Oh, sorry. Command not found. Yeah, I'm getting a different. So let's try to specify the full path. This is my full path. Quite long, isn't it? This is the full path. Command not found. Okay, so I'm getting an error again. So the problem is not due to the fact that I'm not the super user, the root in POSIX system, just like in POSIX system. So the super user in POSIX system are called root user. And again, let me show you again the error. Permission denied. Well, the point is that if you remember, we already mentioned it. Any directory or program can be read, written, and executed by either the owner, the group of the owner, or everyone. Okay? In creating this file, I haven't said that this file should be executed. So by default, the file has been created as a file which can be read and written by myself and read by everyone else. So either we change the permission of this file, saying, look, this file must be executable, or we pass it to an interpreter which will load this file and interpret it without the need to be executed. So, to do it, we may, just to clarify it, we may load an interpreter, any possible interpreter. So it could be a shell, a bash, or any default shell on the system, and provide the name of my shell script. In this way, the interpreter will load the shell script and execute it. Okay, so let's try to do it. Here we are. Is it clear the point here? So I'm not able to execute the script just like a standard command, because this script is not enabled for the execution. So because of this, I may try to execute a shell script and load, and at the same time load execute a shell interpreter, at the same time loading my script and execute it through the shell interpreter. This is what we done by calling sh, which stands for shell, okay, and it's the standard shell of my system, and passing the second argument, as second argument, the name of my shell script. Now, this is a possible way to execute it. Let's have a look at the output on my shell script. So in the first line, we got hello world, which is exactly what we expected because we ran the echo, we used the echo command. And please notice that all the things after the hash hasn't been written in the standard output, so actually this is really a comment, okay? And by using this notation, so the second echo command, in particular the dollar notation, we were able to print the value of the variable A, capital A, in the standard output. And please notice also the very same thing, so the very same syntax as being used to print the output of the B variable, which is actually a variable having a different type with respect to the A variable. So A and B have two different types. A has a value 1, while B has a value string, let's say. But despite this, the syntax for printing the value of the two is exactly the same. This is far different from what we saw in the C programming language, because if you remember, in the C programming language, while we use exactly the same function, so printf to print in the standard output both values and strings, the format of the string, so the first parameter of the function should be in one case %d, in the other case %s. So in some sense, depending on how you want to interpret the value, you have to provide a different kind of output. Okay, in this case you are using basically exactly the same syntax, and according with the type which is implicit of the variable, you are getting a different result. Okay, now, so easy, nothing special, we understood everything till now, at least I hope it. So, have you understood everything? Is it clear? Is it difficult? Is it boring? A little bit, okay? Okay. Now, let's go back to the problem of executing our script. Now, let's assume we want to execute our script in this way. So, without providing any shell script in front of the name of our shell interpreter in front of the name of our shell script, how can we do it? Well, we simply have to say to the system, look, this file is also meant to be executed. And how can we do it? Well, we can do it by using the command change modality. So the command change modality is meant to change the permissions, let's say, of the file. of the directory. So if I want to be able to execute the program, I mean, if I want to be able to execute that file, so that file is not only meant to be readable but also executable, I need to say, look, add to my permission, so plus, the permission of execute it by using the X character. So this command is saying, look, change the permission of the following file and add the possibility of execute it. So, okay, so right now I'm adding the possibility of executing the shell script first.s to everyone. Okay? If I want to do to be the only one able to execute my shell script, I must provide the U letter saying the user can exclusively the user can execute the file. If I want to provide also my group the chance to execute the file, I need to use the letter G, saying my group can execute the file. Okay, without passing any parameter, I'm saying everyone can execute the file. Let me try to execute this command. Everything seems to work as expected. If I list my shell script, here we are. Okay, so having a look at the permissions in this line and in this line, you may notice that something has changed. In particular, now we have 3x. Those 3x means this file is executable both for myself. Well, it's executable for myself, for my group, which is the second X, and for everyone, which is the third X. Okay? And now, if you have a look at the color, well, my shell configuration is meant to provide a different color depending on the permission I have on the file, which is, I mean, this is the default behavior in most of the distribution you may install right now, and also in the Ubuntu distribution. As you may see, the color has changed. Before the execution of change modality, it was white, the color of the name. Right now it has a different color. This basically means that this is executable. So this color is meant to be to signal the fact that this file is executable, to distinguish the fact that it is executable from the other files. Okay? That may or may not be executable. So, once I've done this and my file is executable, I can execute it in this way. So remember the error we got before. The error we got before was an error about the permission on that file. Now we have the permission of execute it. Okay? So easy. Now let me write a different program. For instance, let's assume we want to, let me copy first into second, because I don't want to rewrite everything. Let me close it. Second, move second to second, and gedit second. Okay, now let me delete everything up to this point. Let me change this value, and let me show you that we can also perform a numeric evaluation on this kind of data type. So let's assume we want to compute, by using this program, we may want to compute the how can I say, the division of the value stored in A by the value stored in B. Okay? And how can I do it? Well, I can use this notation. This notation, which is dollar parenthesis 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 parenthesis. This notation is meant to tell the interpreter that what is between the double parentheses is actually a numeric expression which must be evaluated. Okay, and to do it we may write a divided by b. Let's try to evaluate it. Again, let me place second my gedit editor in the background, and let me execute my shell script, and this is the result. Okay, so let me slightly change these values just to let you see that everything works as expected. So as you see here, we are performing, by using that notation, we are performing algebraic evaluation on natural numbers. So the division is a natural division. Okay? But of course we may do also something like, I don't know, more complex like this one. Let me see whether this works. Okay, and this is it. So in between of the double parentheses, I can write a full arithmetic expression. For instance, I can write, I don't know, b. This is a full arithmetic expression. If I write it again, I'm getting this stuff. So the correct answer. This is it. So nice. So we understood that basically the shell script can be used to evaluate numeric expression on natural number. But of course, these expressions are not really useful because by using the shell script in this way, we are basically computing a constant numeric expression. Why? Because the values of the variable inside our used inside our script are actually set just at the beginning of the script itself. So every time I execute this program, I end up always with the same number, which is, I mean, not really useful. So is there a way to pass some parameter to my executable in a way in which I'm able to use these features many times by passing different parameters? So by assigning to those values a different value every time I'm going to run it? Well, there is a way to do it. Let me save it and let me write a third script. So the third script again will use the hash exclamation mark to run the correct, to load the correct interpreter for this script. And okay, and I can, for instance, try to print in the standard output the following things: this strange weird variable, as you can see. This is a variable, we know it because this word, let's say, start with the dollar symbol. So we know that this is a variable because of that. But we haven't seen yet what variable is. And we may use also this variable, and we may try to print also this variable. Okay? So this is a weird program to write. Let's try to see what end up to be. Let me save it and let me execute it. So let me reset first of all the command line, the shell, so the terminal, not the shell, to let also the people here in the classroom see what I'm writing, and let me execute it. So third, I don't know, minus test 3, 4. So here I'm passing to my shell script third.sh also some parameters. These parameters are the equivalent of the parameter which were present in the argv formal parameter in our main function in the C programming language. So if you remember, in the C programming language, the second parameter of the main function is meant to store the parameter at the command line. Okay, and here we are trying to do basically the same thing. So we are trying to read the parameter at the command line from inside a shell script. So let's try to execute it, and we end up with this stuff. So let me change a little bit. Let's say 7. So let's try to understand what's going on. The first symbol printed in the standard output is 3. And by the case, we have 3 different parameters to our program, to our shell script, test, 7, and 4. Let's try by adding a new parameter, I don't know, this is a string, for instance. Here I'm passing 4 parameters. The word test, the number, let's say 7, the number 4, and the string, this is a string. Let's try to execute it, and first value is 4. Oh. So probably, well actually, this is the case. This variable is meant to store the number of parameters passed the command line to execute this shell script. So let me write this. This is the number of parameters passed at the command. Well, let me command line to execute this script. Okay, so we understood this. Let's try to run again. So right now we are printing the number of parameters in a single line, and then we go to the next 2 lines. So let me add another echo just to distinguish what's going on here, and let me execute the program. So the second variable, so this one is printing 7. So here we have 7, which is the second parameter passed to the third.sh script. So it could be the case that this is actually a way to say, look, I want to get the value of the second parameter at command line. Let's try to change the 7 into a, I don't know, string. This is another string. Okay, and let's see. Oh, great. So our guess was actually correct. So if we change the second parameter of the command line, we end up in printing it in the standard output by using this notation. So this value, so this variable store the second parameter at command line. Of course, I mean, we can also try to print the first parameter. Instead of writing $2, we might write $1, and we end up in printing the first parameter. If you want to print the, I don't know, fifth parameter, we simply have to write $5. Okay? So this is a class of parameters, let's say. A family, a set of parameters, of variables, sorry. This is basically equivalent to the second parameter in the main function in the C programming language. So the second parameter in the main function in the C programming language was what we usually called argv, okay? And the first value in argv was, well, the value in position 1 in argv was the first parameter, the value in position 2 was the second parameter, and so on and so forth. Here we have exactly the same thing. So $number is a way to say, look, I want the ith parameter in the command line. And what about the third weird variable? Well, the third weird variable, let's have a look at the program. Here we are passing as a 3 parameter test, this is another string, 4, this is a string, and by printing the third variable we end up in test, this is another string, 4, this is a string. So probably this variable, well actually this is exactly the same case, this variable is meant to store all the parameters provided in the command line. Provided at the command line. So this variable stores all the command line parameters. This is it. So quite easy. Okay? So, okay, by using these 3 variables, we are right now able to write a shell script which is able to take 2 parameters at the command line and evaluate the sum of these 2 parameters. Okay. Okay, so let's try to write our program. And let me think what we were doing. We want to, okay, we want to evaluate the sum of 2 parameters. So let's try to echo, this is the way, I recall you that this is the way to say, look, what inside the parentheses is meant to be evaluated as a numeric expression. We may try to do $1 plus $2 and return 0. Okay, this is a shell script. Let's try to execute it. Three and 4, for instance. Oh, by the way, okay, let's run it with 3 and 4. Oh, sorry. I wrote return, I was wrong. We need to write exit. And I try to execute it back. Okay, so this is the result. Let's try to change some numbers and we end up with a different result, which is the correct one. So now we are able to take the values as in the command line and execute some operation on them. What if I add another parameter here? Nothing changed. So since our shell script is not dealing with that parameter, we end up with that avoiding to use it. Okay. And what if I provide 1 parameter instead of 2? Error. Okay. And that's normal because our program was meant to use 2 parameters and we are providing just one of it. So the shell script is not able to understand what's going on. How can we solve the problem? Well, we can solve the problem by using the if statement, which is also implemented on in the bash. And the syntax for the if statement is the following one. You have if, then square brackets, semicolon, then, and then at the end of the block of the instruction you want to execute a fee. Okay? And okay, so our condition will be included inside the square brackets, and yeah, we want to say, look, if you are trying to execute this shell script without passing exactly 2 parameters, you must end up in an error. How can we do it? Well, we need a condition to decide whether the number of parameters in the command line was 2 or not. So we understood that this variable is meant to store the number of parameters in the command line. And how can we say different from? Well, if I use this syntax, I end up in a problem because this syntax is meant to deal with strings in the bash. Okay? So I can try to do these things, which is not exactly what we want. It could work, okay? It worked. But I mean, we are not trying to compare a string with another string. We are trying to compare a value with another value. So this is a weird way to specify this kind of stuff. The best way to do it is to use the comparison in the shell script, which is implemented by -ne. NE means not equal. Okay? And there are tons of different ways to compare values. So we have, for instance, -eq to say equal, or less than, which is -lt, and so on and so forth. I mean, you will find some of them, some of these relation, arithmetic, algebraic relation mentioned on the slides. However, for our purpose, the difference, the relation different from is enough. So this is a way to say, look, the number of parameters passed to the command line is different from 2. And in this case, what can we do? Well, we can print in the standard error a message. And to do it, let me use this notation, which is new to you. The notation tells me that, so I'm using parentheses to tell that everything in the middle of the parentheses must be handled in the very same way. So just like a block of distraction, let's say. And then I must say that everything I'm writing inside of this block of distraction must be written in the standard error, and we already know how to do it because we saw how to redirect the output of a command. And once I've done this, I can use the echo command. So echo syntax error, for instance, syntax error expected 2 parameters. Oh, 2 parameters expected. Much better. Okay. And of course, we must exit our program. So once we discover an error, we must conclude the execution of our program, and I mean, let's assume that the code 1 is enough to say, look, this is an error. Okay, let's try to execute the program. and we got an error. Let's try to execute the program by using more than 2 parameters, and again we got an error. What if we, and let me reset the terminal just to let you in the classroom see what's going on. Let me execute the program exactly with 2 parameters, and this is it. Okay, is it clear? So nice. Okay, let me show you 2 more things, which I think is really intriguing. Okay. Here we are. Okay. So let me write another program. Let's assume we want to repeat the same. Yeah.
Gives me a different error.
Okay. What kind of error gives you?
It says file 3, 1 not found, 2 found. Then it says.
Okay. 1 not found. Okay. Are you sure to have placed the semicolon just after the
Yes.
so the syntax of the if condition is correct?
It's exactly the same.
Exactly the same. Do you mind if I come near to you just to have a look at? No, stay there. I simply want to understand what's going on. Give me a second. It's really important to try to place a space between the square brackets and the variables. Let's try to do it. Now it works. Oh, okay. Okay, so the problem was related to the spaces. Okay, this is a really important thing to mention, which I wasn't mentioning because I'm used to do it. So if you try to change your program, so let's try to change the program and remove all the spaces between the variables. So let's try to do this way. So first of all, you notice that our program changed. So the color of the condition has changed. Okay, of the bracket has changed. This is white. This is a different color. And this is due to the fact that usually full words are meant to be interpreted all together. So, for instance, let's assume that I want to print the content of the variable 1, and then after the content of the variable 1 an underscore. Okay. Well, this may be a problem. Or if I want to print just, well, let me change a little bit my example. So let's assume we have a variable a, okay, and I want to print the content of the variable a, and just after the content of the variable a, I want to print hello, capital hello. Okay. This may be a problem. Why? Because since there is no space, all this stuff is interpreted as a single object by the shell script. And that's why I told you that the bracket notation is useful. Because if you want to do this kind of stuff, you have to place bracket telling, look, my variable is, the name of the variable I want to deal is A, and not ALO, okay? And this is a way to tell our interpreter that actually this stuff is different from this one. But usually the interpreter tends to collect all the character but the space as a single object in our program. And that's why if you don't place a space in between the square brackets and the $hash variable, you end up with an error. Because you get something like, I don't know what is open square bracket 1. So let's try to see what's going on. This is an error, okay? Here I'm passing two parameters, 3 and 4. So $hash is substituted by 2, contain the value 2. Now, if I want to compare algebraically this value with this value 2, the first object, so the object coming just before minus and e, must be a natural value. And since actually you have the open square bracket just before $hash without any space, the interpreter takes the whole open square bracket value in $hash as a single object and try to use that object and try to compare that object with 2, which from an algebraic point of view, of course, is not possible. Okay, so that's why I place a space here, because by doing this we are saying that you want to compare numerically the value which came before, which in this case is only 2, with the value that comes after minus and e, which is 2. Okay? So the correct thing to do is to always place a space to be sure that that object is handled by its own. Okay, this is it. So let me try to move on, and let's assume we want to repeat some kind of operation. So how can we do? We can use, let me close this program which now is working as supposed to do. Let me get it fifth. That. How can we do? Well, we can use the for loop. We have embedded a for loop also in the bash too. So for instance, if I want to repeat a given operation for many objects, I can use the for loop, which has the following syntax: for name of the variable over which I want to iterate in, and the set of objects over which I want to iterate. So it could be a name here, I don't know, string, or a number 3, or whatever you want. Okay. Again, the list of objects over which I want to iterate is ended by semicolon. And after this, I need to place a do saying, okay, this is the header of my for loop, but after the do, I'm basically reporting the blocks of a command I want to repeat. And this can be done by in this way. Done. Okay, so the block of commands you want to repeat are basically included in between a do and done. Now let's try to see what's going on here. And as fifth. Here we are. Oh, let me extend this is a string. Okay. So quite easy. Can I do the very same things on the parameter? Let me see. So can I iterate over all the parameters past the command line? So let me call it par, for instance. This is better. Name is a parameter. Command line parameter. Command line parameter. Done. Let's try. P1, 2. This is the third part. This is the third parameter. Here we are. Oh, here we have an error because I placed name instead of placing par. Let's try to repeat. Okay, so let's try to have a look at what's going on here. So this is the list of all the parameters of the command line. By using the for loop, I'm taking each word in the parameter of the command line, despite the fact that one of the parameters is a string. And I'm printing on the standard output, as you can see here. So here we are providing actually three parameters. The first one is P1, the second is 2, and the third one is a string. And this variable is the list of the parameters. However, the for loop is not going through the parameter, it's going through the words in the parameters. Okay, so this third parameter is actually split into all its words. Okay, nice. Can we do better than this? So let's assume we want to print in the standard output one single parameter per time. Well, this is the for loop. Let's have a look at a different way to specify a loop. And you may imagine what's next. So let me write a different program. Being bash and I equal to 0, while while what can I write here again, while I is not equal to what? To the content, the number of parameter passed in the standard output, do the following things. Here you see we have another way to specify loops, which is as in the case of the C programming language by using the while loop. The while loop is has basically the same semantics of the one we saw on the C programming language, and the syntax is quite similar to the for loop, of course, but you don't have a variable over which you are iterating necessary. In this case, actually we have is the variable I. We are iterating on the variable y, going from 0. I will be assigned every time to I plus 1, meaning I'm increasing the content of the variable y, I, by 1 each time I enter the for loop, and then I echo what I can echo $1. Oh. Okay. Let's see if this works. Okay, I'm getting okay, let's change my example. Instead of printing the because I mean this might be done in a different way. So let me simply print all the numbers from 1 up to the first parameter, which is much easier, so I don't want to mix up too many things at the same time. Let's try to do it. So let me say I want to print all the numbers, all the positive numbers from all the positive numbers up to 12, and this is it. Okay. And okay. Okay, let me see here. 4, 6, okay. Now, let's assume we want to. We have written a batch of file. Okay. Let me go back to the shell. This is it. So we wrote first, second, sixth, third, fifth, fourth, and so on and so forward. Okay, and let's say that I want to change. I want to change let's say the extension of my file, because for some reason I don't like them. Okay, and I want to change the extension to txt. This is my goal, for instance. So how can I do it? Let's try to write a program which is able to change the extension of all the files whose extension is sh. Let's try to do it. So edit, change text. and let me call it sh. So how can we do it? Well, first of all, we need again to say this is a bash script. And let's assume we want, for instance, write a very generic script which takes 3 parameters. The first parameter is the path of the directory in which we want to find all the files. We want to change the extension. The second parameter is the source extension we want to change, and the third parameter is the final extension we want to have. Okay? So our program must contain 3 parameters. So how can we say it? We can use, as usual, the if condition. If and the number of parameters is not equal to, we said 3, we may write echo syntax error. Let me think. Directory called next new text. Okay, this is our command exit 0. Now, okay, so now we have to go through all the file name in what? And now we have to read the content of the directory passes parameter, and we have to filter it in a way in which we are basically reading exclusively those files. Extension is the second parameter. Okay, so how can we do it? Well, to execute a command inside the script and taking its value as a variable, we have to use this notation. So this notation is quite similar to the notation we already saw to interpret, to execute a numeric evaluation. This $parentheses single parenthesis notation is meant to evaluate a command and return the result as it was a variable. Okay? So, if I write ls $1 slash $2, I'm basically asking my shell to print in the standard output the content of the variable passes as the content of the first parameter, which is a directory, which matches $second parameter. The second parameter is the old extension. So basically I'm saying, look, I want to know all the files having that extension in that file. Okay, and this command is executed, and the result is handled as it was a value for our shell script. So by doing this, then I need to do done. And what's next? Well, I can do the following thing. First of all, I need to remove. I need to take the name, the true name of my file, and in particular, I need to remove from the name the path and the extension. How can I do it? Well, there is a new name. There is a command. So again, I need to use this notation. There is a command named base name, which is precisely meant to remove the path from the file name and possibly also remove the extension. So if you write base name, name of the path, name of the file, everything but the true name of the file will be removed. Okay? And if you pass to this command also another parameter, that parameter is the name of the extension you want to remove. So by doing so, you basically end up in removing the last part of the file name. Now, once you have the new name, you must obviously use the command move. Since we don't need to take the standard output of the command as a parameter for our shell script, we may write it as it was in the command line. So move from fname to $1. Move fname to what? Now, this new name is the name of the file we want to deal with. Once we have removed the directory in which is the file and the extension, so we have to reintroduce the directory. Otherwise, we are moving that file from one directory. We may move that file from one directory to another one. So that's why we are using the $1 notation. New name, which is the name we have just got. Well, probably instead of new name, could be useful to call it base name, meaning is the base name of the file, and then we must introduce back the new extension, which is stored as third parameter in the command line. We end up with this command. Now, this program should be correct, but of course, if I run it, I end up changing things in my directory. So, first of all, the best thing to do is to have a kind of simulation of what's going on. So, to have this kind of simulation, instead of executing this program as it is, I slightly change the things, and first of all, I want to print in the standard output the command instead of executing it. Okay? This is a way to emulate the execution. So instead of performing the true things you want to do, we are printing the standard output, the command that will be executed eventually. So this is our way. Let's try to execute it. X6. Try to execute it. Oh, we end up with an error. Line number 5. Oh, no. We were executing the wrong file. Let's try to... Okay. Here, expected... Oh, here I missed to write then. That's the first error. Let's try to execute again. Okay. Now we are getting a syntax error, meaning that our file is meant to execute it with 3 parameters. The directory in which we want to execute it, the old extension and the new extension. So let's try to provide as directory the current one, the old extension will be sh, and the new extension will be txt. Okay? Or rather, let's try, but txt doesn't change. This is just to test it. I mean, it's not really smart to do it, because in this way we are, by changing the extension, we are not really changing the property of the files, but in some sense we are telling who is seeing the file that that file is meant to store a text rather than a shell script. Okay, so let's try to execute the command, and we end up with this command, with this standard output. So here you can see as what's going on basically, which is basically what we want to do. So once we understood that everything works as expected, we may remove the echo command and leave the command itself there. This is it, and try to execute. So first of all, let me have a look at the directory. This is the directory. So as you can see, all the files we have just written are have as extension sh. If I run my shell script, I end up in something different. Okay? And of course, I mean, I can, in any case, I can call the script even though I've just changed its name, the extension. In any case, I can execute the shell script as before, simply by changing its name in the command line, and I can go back to the previous situation. Okay, so as you see here, we were able to write a shell script which is interacting with the file inside our systems and give us the chance to avoid to rename one by one all the files in the directory, in the current directory, or better, in any directory in our systems. I don't know whether you can do the very same thing in a smart way by using a graphical user interface. So is it possible to change the extension of a file, a batch of files in graphical user interface? A single one, well, a single one is easy. But I was wondering if you want to change all the extension of all the files having as extension SH in TXT. Is it possible in a smart way in a graphical user interface? I don't think so. So as you can see here, by using a shell script, we were able to arrange something which can be easily called and used many times in many different directories in, I don't know, 10 minutes. So this is extremely powerful, okay? And this is it. Any question about it? Okay, on the slides you will find also the fact that in shell script you may also implement functions, which is pretty cool things. Okay, so you may implement functions and use function as we did for the C programming language. Cool. Now let's have a break. And we will see a different topic later on. Oh, by the way, I already told it, but on the slides of the current lesson, or lesson number 8, you will find everything we saw until now, and also the latter part of the lesson. Okay, so don't worry if you have missed something. In any case, you can write me even after the pre-course. So if I don't know, in the middle of the first semester you end up in saying, no, that both things we saw with Professor Casagrande, but I cannot really remember how it works. Don't worry, just send me an email and try to reply you as soon as possible. Okay. That's it. So let's have a break, 10 minutes.
neanche un'aula non c'è. Ah, non ci sono. Non c'è la possibilità di cercarli. Sono in ordine sparso. Mi sembra veramente fatto benissimo. Okay.
Let's go back to our stuff. And let's move to a different topic. The topic I want to introduce is something extremely useful if you write programs, or I don't know, if you write a thesis or any kind of document which requires interaction from many stakeholders, or I mean require many reviews, let's say. And the things I want to introduce is a tool for revision control of your project. In particular, we are going to talk about Git. Git is a tool to take memory of the revision you had in your project, and it has been specifically designed to give you the chance to work in a distributed way. So basically, many persons can handle the very same project, and all of them has their own, let's say, database of changes, and they can sync from time to time all together to one or many different online repositories. But to introduce it, let me just show you very plain commands and how it works offline first. So here we have a program, really simple program, you may see, which print in the standard output hello world. Okay, nothing special. We already see something similar many times, so it's a really simple program. Well, this program can, of course, be compiled as usual, so we can produce an executable. By default, the executable will be named a.out. If I execute it, I end up with this result in the standard output. So it's, I mean, a standard program, nothing special. And so let's say this is the first revision of our well, not the first revision, but let's say we want to have the chance to remember all the revision of our project. This is our project, and I mean, at the beginning is quite simple, but may grow up to be an operating system or something similar. So that's why we decided to go for a revision control tool, and in particular we decided to use Git. And how can I start a new repository for my Git tool? The repository for Git tool is a place where all the revision and all the changes to your project will be stored. Okay, and here we are going to start a repository offline, namely on the project directory. So without having any remote server to which we are going to sync our project. So how can we do it? Well, we can do it by issuing the command git init. So the git init command is meant to initialize a new Git repository. By issuing the command, we end up with this or this string, or better something similar, because of course here you can see the full path to my test directory. Okay, so Git is telling us that an initialized Git repository has been built up for us. Now, the first thing we may want to do is to see what's going on in our repository. So a useful command is git status. Well, git is the command, the parameter is status, which is meant to see what's going on in our repository. So whether there are files which are not included into the repository, which are right now present in our directory, and to see whether some files which are included in our repository have been changed. So let's issue this command, and we see that, well, I hope you can see, but I'm not sure about it. Here we are told that at the moment we haven't committed any version of our project to the repository. There are a few files that are not considered by the Git tool. So untracked means that these files are not present, let's say, in the repository. They are not dealt by the repository, and the last command basically is saying, look, nothing new to the next submission, let's say, but there are some files that are not present, that are present in the directory but not present in the repositories. And these files are the files in our directory. If we have a look at it, we end up with this. So the directory basically contains exclusively those two files. Okay. Now, how can I add a file to my repository? Well, there is a suggestion down there about how to do it by using the command, again, git and the parameter add. So let me reset the directory, and I can issue the command git add main.c. By issuing it, no message from the standard output. On the standard output, again, if I repeat git status, I end up with something changing the status. So on the status, I can see that while the a.out file is still untracked, the file main.c, so the source file of our program, is planned to be committed. So this file is a new file for the repository, and the next time I'm going to send something to the repository will be included in the repository itself, along with all the changes I have already performed on it. Okay? Is it clear at this point? So right now we have created a repository, so a place where to store all the changes for the file in our project. But at the beginning the repository is empty, so no file are being included to be remembered, let's say. To do it, we have to add a file or a set of files to our repository. And the thing how can we do it? We can do it by using issuing the command git add. Git add that file to the repository, and so from this point on, all the changes will be remembered, let's say. But at the moment, I mean, I haven't yet submitted anything to the repository. I'm simply saying, look, I want to add a new file the next time I'm going to submit something. Okay? And so at the moment, if I have a look to to my repository, still it doesn't contain anything really. How can I submit something to the repository? So how can I submit all the changes I've made until now, and I have decided to remember? Well, we can do it by using the commit command. So let me reset again the terminal by using git commit -m. So git commit is a way to say, look, everything I've added to the next, everything has been added to be submitted to my repository must be submitted right now. Okay, and every commit must include a message. Let's say there are two ways to provide the message. Either by issuing the command git commit, and you end up in an editor in which you are requested to provide a string, let's say a sentence, or by using the parameter -n. -n tell the command line that what's come next is basically the text you want to use as submitting text, as commit text. Okay. And here, for instance, I can see, I can write my first commit. And by executing this command, I end up with this stuff. So I don't want to enter in all details about what's going on here, but basically, this is a way to say, look, you have just submitted a new version of your project. This project includes a new file, just inserted. The file has 8 lines, because you inserted 8 lines to the file, and this is the name of your submission. So this is a weird hash, which is like a number, submission number, and every time you will talk about this submission, you need to provide that number, basically. Now, okay, this is our first commit. Let's try to see what's going on our repository and our projects directory by issuing again git status. Now, if you remember, we had a message saying no commit yet. That message has gone completely, so we don't have anymore that message, and this is due to the fact that, of course, we have just committed a revision for our project. We have again the untracked file message saying that there is a file inside our directory, inside the project directory, which is not tracked by our repository, and that's all. Now let's try to do something. In particular, let's try to change our program, and this can be done, for instance, by adding a line here. Nice, this git, and maybe we may add 2, well, just 1 new line. So I'm changing, basically I'm changing the main file. Let's try to compile it and execute the app.out file. Here we are. Okay. So right now I'm not using Git. I'm simply changing the source of my executable, and I perform some changes, minor changes, but still some changes. Let's see what's going on in our repository. Oh, let me do in the status. Here we are. As you can see, something has changed also in the status, and the status of my repository is saying that I've modified the file main. Something wrong? What's going on?
Please tell me who you are.
Pardon?
Tells me. Please tell me who you are. Set your account default.
Oh, give me a second. I want to see this error message because I haven't seen it. Okay, so give me a while. I'm going to see the error one of your colleagues is getting. Oh, okay.
I tried. And it doesn't work.
So you try to issue in that command.
I tried root and
You're missing global.
no, I
It's
can,
not yet.
I can recall.
But let's try to do it global, just to see what's going on.
I saw close without the global sensor.
No, for your name probably you have to use the quotation. So name and surname, the name and surname should be included into
The
quotation mark.
name with the question mark and the mail without it. That works more for me.
So let's try it. Okay. Put that in single tag. Username has multiple tags. Because you. Okay, so delete. Let's do it from the scratch. So issue remove minus rf dot git. Enter. So okay, great. Let's try to create. So recreate it. Yeah. Okay. Now again add main. Git. Add main. Okay. Git commit. Space. Yeah. Now git commit. Okay. Okay. Now let's try to this one and this one. Okay. Now let's try to commit. Oh, this is really weird. Oh, that's the problem. Okay. Okay, we had an issue in the command issue by your colleague, and that's why there was an error. Okay, finally. So let me go on. Now, here we are. So after issuing Git status, we land in a situation in which the Git repository is telling us that we have modified the main C, but nothing is great. But nothing has been planned to be sent to the repository. Okay. So by changing, are you still with me? Are you still with me? Yes. So So we changed the content of the main file, which was submitted by issuing the git commit, okay, to our repository. We change it, and then by issuing the command git status, we land a situation in which the repository itself is telling us that the file has been changed, the main file, main.c file has been changed, but yet it hasn't. Those changes have not been planned to be submitted to the repository yet. Okay. So if I try to issue a commit right now, I'm not committing anything. Why? Because I haven't told my repository that I want to submit the changes. Despite the fact the main file, main.c file is present in the repository. At this point I've changed it, but I haven't told Git, I haven't told Git that I want to submit the changes. So how can I tell Git that I want to submit the changes? Well, by using git add again. So git add is meant to add the changes I have performed on my project to the repository. Okay. So if I issue the command git add main.c, I'm telling my Git repository that I want to, I'm going to, not done yet, but I'm going to submit those changes to my repository by issuing git status. Well, let me reset the console just to let the guys on the classroom see what's going on. Okay, now, after issuing git add, my Git repository is telling me, look, you have changed main.c, and that changes are going to be submitted to the repository. And I have the chance to go back to my previous situation if I want. Okay? And to do it, I can use the command git restore. However, let's say I understood that my main file has been changed, but I don't know how. Let's assume that we don't remember the changes we have done on our main file. How can we figure out what's going on? So what changes we have done to our file? Well, we can use git diff. So git diff give you, oh no, already, well, not really, but well, let me, no, not yet. So git diff actually give me the chance to see the difference between the change file which hadn't already been planned to be submitted. So let me change again something in the file. So let's assume I print here third, for instance. So I'm changing the file and I issue git diff. And right now the git tool, sorry, is telling me that the difference between what isn't already planned to be submitted and what is actually planned to be submitted is that line, and you can see it because we have a plus here saying this is a new line, wasn't present in the list of things that are already present in my repository or are going to be submitted to the repository. Okay, so let's assume we don't want that line. So how can we do it? Restore main.c. So if I have a look at my file right now, this is it. So by issuing git restore, I'm able to go back to the situation which has been planned to be submitted to my repository. Okay, so this file is not already present in the repository. I only plan to submit it to the repository. By using restore, I was able to go back to that situation. What if I want to go back to my last submission? So let's assume we changed this file. We have planned to the submission, but we haven't submitted yet. And we want to go back to the previous situation. So the situation which has been already submitted to the repository. How can we do it? Well, again, we can use the restore command, let's say, by using also another parameter which is stage. This is it. So in this way I'm saying, look, I don't want to go back to the staged, so to the changes planned to be submitted. I want to go back to the last version in the repository. So let me cut the main file, and this is it. Okay. And okay. Yeah, we are modify. Let me add. Let me see the differences. These are the differences. Let me add it. Let me add again the changes. Well, no. Let me reset. Restore main. Here we are. Let me cut it. And so this is the original file on the repository. So by issuing restore staged, we remove it from the plan submission, let's say. By issuing again restore, we end up with the original file. And that's more or less all. Yes. Okay, now, from time to time, it may be useful to have many different versions of the same project. Why? Because maybe the case that you want to introduce a feature which takes a lot of time to develop, and meanwhile you want to maintain your older code. Okay, so let's assume you are dealing with a large project, and from time to time you may happen to discover a new bug. Okay, and you want to being able to solve the bug as soon as it is possible, but at the same time you want to make your project advance by introducing some new feature. Okay, and these two, let's say, workflow are quite different in time scale. So introducing a new feature may take much time, months. While solving a bug should, at least in theory, takes at most 2 days. Okay, so in some sense you may want to have two different workflows for the very same project. How can we do it? Well, one possibility is to have one Git repository for each of the two versions of the projects you are working on. But of course, this is stupid, okay? Another way is to use what is called branches. So what are branches? Branches are different concurrent versions of the very same project. The idea is to have many different workflows of the same project evolving independently and give you the chance eventually to merge them back. So just imagine the workflow, the development workflow for your project just like a tree. every time you need to add a new feature which is unrelated to other feature you are working on or unrelated to your original project, let's say, you may add a new branch, and that branch will be meant to deal exclusively with that feature, new feature. Okay. Once you have a final product for that new feature, so once that feature has been frozen, let's say, you may go back to the main project by merging all the source code you have already introduced to add that feature to your main project. And in that case, that branch will be included in the will be merged with the principal branch of your project. Okay. So let's see, how can we handle it? So if I issue git branch, I end up in seeing that my repository has at the moment one single branch, which is the master. So the main principal branch in the tree. And this asterisk is meant to say, look, the branch, the active branch, so the branch in which you are working right now is exactly that one. Of course, since you have exclusively one branch, it's not really meaningful at this point. But let's add a new branch. How can we name it? Let me see. I don't know. Let's say new feature. I mean, new feature is not a good name for a branch because it doesn't tell you anything. But I mean, this is just a demo, so you know what I mean. So if I do it, nothing happens apparently, but actually something happens for sure. This is it. So by issuing git branch with the name of new branch, I end up adding that new branch to my repository. Now in my repository I have two branches. The first one is master, which is the main branch in my repository, and the second one is new feature. At this point, they are totally identical, but I can select one of the two and I can progress with my code exclusively in that branch. So for instance, how can I select new feature? Well, to select new feature I can select checkout, I can use checkout or switch. Well, checkout works pretty well. Also for new feature. So by issuing this command, I move from the master branch to the new feature branch. My Git repository, my Git tool is still telling me that I switch to that branch. If I issue get branch, git branch, now you can see that my active branch is new feature. Okay, so right now I'm working on that branch, not on master. So the master will remain unchanged while I'm changing the new feature branch. And let's have a look. Let's have a look at this code. This is my code. The code I got in my repository. Let me see the status of my repository. So nothing has changed. Here my Git status is telling me that I'm on my current branch is new feature, so it's the name of my current branch. And here I can add files. So I can add files and can change my code. So first of all, let me add a very specific file, which is meant to deal with the situation in which you don't want to be warned about a file which is always present in your project directory. So, for instance, here, every time I run git status, I end up this warning, which is about a.out, which is a file that for sure will be present in my project almost all the time I'm issuing git status. So I can say to my Git repository that I don't want to be warned about that file, because I'm not going to add that file to my repository for sure in any case. So how can I tell my Git repository, look, I'm not interested about a.out. I know I have it in my project, but I'm not going to add to my repository, okay? My project directory. I'm not going to add it to my project. To my file. Well, to do it, I can use a file named git ignore. Okay, so let me clarify. If I do echo a.out git ignore. By issuing this command, I'm creating a file named .gitignore, and that file will contain one single line, and that single line will be a.out. Okay? So, running the command, I end up in this situation, nothing has changed. If I have a look at my directory, what's going on? What do you expect to see if I issue the command ls? Any guess? Pardon? Can you speak louder because of you will see what? So you are saying, let me repeat because I'm not sure. So you are saying that we are going to see the file a.out, the file main.c, but we are not going to see the file .gitignore. Okay, how many files do you expect to see from as an output of the ls command? So the ls command lists the files in the current directory, right? And we have 3 files in our current directory that are we have apparently 3 files in our current directory which are the main.c, the a.out, and the .ignore, gitignore file we have just created right now, right? So you may expect to see 3 files, right? Oh, correct. So the point, we are going to see exclusively 2 files. Why? Because by default, the ls command discharges all the files name starting with a dot. So the gitignore file will not present in the output of the ls file, of the ls command. To see it, we have to issue the command ls-a, which provide us, which give us 6 actually outputs, 6 things in outputs, let's say. Well, the first one is the current directory, so the dot. The second one is the parent directory of the current one, which is 2 dots. We have the a.out file, which is, expected. We have the main.c file, which is expected as well, and the gitignore file, which is expected. And then we have something strange, which is the directory .git. What is the directory .git? Is the directory physically containing the Git repository we are using right now. So by issuing the command git init, Git create an hidden directory inside the current directory, and that hidden directory is called .git. Okay? And that directory will contain all the files required to store the changes to your project, basically. Any question about it? Is it clear? Clear. So right now, if I write, let me reset, git status, I end up with something strange. Again, I have an untracked file, but the untracked file is no more the out.out file, but is the .gitignore file. Why? Well, the gitignore file, I recall you, contains a line a.out. This file, so the .gitignore, is meant to tell Git, look, I'm not going to deal with these files. So Git doesn't take anymore into account the a.out file anymore, the a.out file anymore. Okay. But despite this, is still wondering what is .gitignore. It's not present in the repository. So if you want to add it to the repository, you have to add it explicitly. And this is what we are going to do. So git add. Well, not yet. We will use another way to do it. Now, despite this, we haven't really changed our code in the branch new feature. Let me add a really new feature. So in the previous code, let me show you again. Oh, we have to compile it. In the previous code, we have this line. So the output of the execution, after the execution of our code, we land with the hello world printed as the standard output, but we are not going to the next line. So let's assume that our new feature is, first of all, try to oh no, let's leave the things in this way instead. So this is our code. Our new feature will be to print something else. So print f, for instance, nice day. Have a nice day. Have a nice day. Okay? And this is it. So this is our changes at the moment for our repository. Let's have a look at our status. So here we are warned by our Git that the changes in main are not staged for the commit yet, and there is an untracked file. So first of all, so again, we can add everything by using to our next commit by using add, or we may use something else, which is, well, let me add this one, add git. So at this point, that file has been added for the submission. But we haven't staged for the commit the changes we have performed on main. So either we again use git add, or we may use a special parameter of the commit command, which is -a. So if I write commit -a, I'm saying, look, I want you to first of all stage every change in the tracked file on the project directory, and then after planning for the submission of all the changes, commit it. Okay, so by writing -a, you are basically saying if you have a track file which has been changed, add it to the next commit. And so this is, let me call it commit number 2. Here we are. Okay. Now I create a new file. And here I'm warned, I'm notified that I've changed 2 files: the git ignore, which weren't present in the repository before, and the main file. Okay, and there are 3 insertions, which are due. 2 of them are due to the main file, and the last one is due to the git ignore line. Now, right now I can also ask myself, but what are the differences between my my current branch and the master branch? Okay, so let's assume we want to know the difference in terms of source code. How can I see the differences? Well, I can use again git diff, which tell me the difference between something and something else, and I can provide the branch I want to compare with the current one. So by issuing this command, I end up in this output. This output tells me that so this is to say, look, the original file wasn't present, and this is the final file, and the final file has 1 line more, which is this one. Okay. And what about the remaining part of the? Can you see the last lines of my output? Well, and the remaining part is about the other file I've changed, which is the main file. As you see, in the previous version, so in the master version of my file, the master version of my file was called main.c. The final version, so the current version of my file is called main.c as well. And the differences are that I have added 2 lines, and these are the 2 lines added to my source code. Okay. Now let me go a little bit further and try to compile my code. So remember, I'm still on the new feature branch. Here we are. Okay. I'm compiling my code. I'm seeing what's going on with my code. Oh, awful. Everything is 1 single line, and especially after I have a nice day. I'm not going to a new line. So the prompt and the output of my file are exactly on the same line. This is an unwanted feature for myself. So I want to change it. Let's try to change it. Go to the source code. To do it, let me add this. Escape sequence. Let me compile again my source code. Let me execute. Oh, nice, much better. So again, let me go to see what's going on. Now I have changed my new feature, and my new feature is working as I want. Okay. Let's see status. I changed something, so let me make another commit. And my commit is new feature is working. Okay, let's do it. Now, this is it. Okay. Oh, yes, of course I can have a look at the changes on my repository by using git log. So git log provide me all the commits on the current branch. Of course, oh, yeah, I was using two exclamation marks, which means something really specific in the shell. So they are replaced by reset. This is an unwanted things. So let's assume this reset is a double exclamation marks. Okay. Now, of course, my commit messages are not really relevant. I mean, I don't know anything about what's going on here, but still, if you had provided some useful piece of information, you have a list of all the changes you provided to your code. Of course, I can still see the changes between one submission and a new submission and an old submission. For instance, this can be done by, let me take the first few characters, the commit, hash code. So this is basically saying this commit has this number defined in it. However, this is a long number, and you can take exclusively 6 characters, I think is enough to define that specific commit. And so I can, for instance, asking myself, what's the difference between the current version of the code and this version of the code? And I end up with all the differences. Okay. Please notice this is the difference between the current version of the code and the version at the very beginning of my. So after the first commit on my code. And by the way, let me go back again. If I have a look at the log, I end up in seeing that at some point. So going back in the log, I end up in the master. So my branch started from the master branch. And this is reported in between a parentheses, just after the number of the commit. This is an ID for the commit, okay? This is quite long because, of course, if you are dealing with many projects, you may end up in a mess. But usually 6 characters are enough to characterize that ID. Okay. This is more or less all. Okay. So now I finished my feature, but meanwhile someone else, which is working on my project as well, or on the same project I'm working, may have discover a bug in the let's say original repository. So let's go back to the original repository. Reset. How can we go back to the original repository? We said that we may use checkout, but we may also use switch master. Okay. So I've switched to master. So the checkout command is meant to move along the branch on every single possible commit you have committed, okay? So if you decide to go to the previous commit, you simply have to select the first 8 characters in the ID of the commit and write git checkout and that numbers. The switch command is specifically meant to switch to a specific branch, to the last commit of the specific branch. So now we are in the master. If I cut my main file, I end up with a version in the master branch. And of course, my executable is still, since the executable is not stored in our repository, the executable is still the one we had with the previous compilation, with the last compilation, which was the last version in the new feature branch. So to have a consistent executable, we have to recompile, of course, our source, and here we are. And again, another guy discovered that there is an error here, because again, after printing on the standard output hello world, we are not going on the next line. So this is a bug, okay? This is a bug in the original version of the software, not in the version of the new feature. So again, here you may, while you are still working on the new feature, you may want to fix this bug, and to do it, simply fix it on the main branch. Okay? And let's see what's going on. I compile it, and this is it. So solve the branch. Of course, once you have solved the branch, you still need to commit the changes. So commit everything, and as a message, solved bug number, I don't know, 1, let's say. Okay. Let's assume that you were notified that of that bug, and that bug has been named bug number 1. So in the commit, once you have solved that bug, you need to say something like, okay, I solved that bug. This is just to be informative with respect to the difference between the previous commit and the next one, okay? This is it. Now, so now we have solved your bug. Let's go back to the, let's assume that, okay, let's go back to our new feature. New feature, switch to new feature. Okay. And okay, so the bug I solved in the main branch is not related to the feature I have just added in this branch. Okay, so I want, in some sense, I want to add in the new feature branch, include the solution for the previous, the solution for the bug, which right now is present exclusively in the master branch. Okay, so how can I do it? Well, I can do it by using the merge function. So merge master. So by issuing this command, I'm merging what has changed in the master branch in the current branch. Okay, so all the changes has been performed and committed to the master branch will be included in the current branch. Let's see. Merge branch master into new feature. Okay. Okay, Control X. Okay. This is it. Now let's have a look at the code. Here we are. Okay. So as you can see here, I've fixed this bug, and at the same time I've included the new feature. So the new feature come from the previous commit of my new feature branch, and the fix of the bug number 1 comes from the master branch, and they are included in the very same piece of code automatically, which is nice. So I don't have to take care of, okay, this line has been added in that piece of code, this line has been added, everything is automatically recorded. So let's have a look at the status. Nothing to commit, everything is nice. Hit log, and here you have all the feature. So all the commit you have performed on the current branch that I recall you is the new feature branch. Now let me stress one thing, last thing before leaving you. Let's assume that for some reason your new feature code require to change that lines. Okay, so your new feature basically is hiding this line, is removing this line from the code. Okay, you are changing a line. This is the first line in your program. And let me again commit it. Status commit. Item number 2. Let's say. Okay. So now I've committed this line in my new feature branch. Let me go back, switch back to my master branch, and let's see the code. This is my code, and let's assume that at some point, this is still a bug for me, because I want to go to add 2 new lines and then after printing hello world. So let's assume we want to do these things. Okay? So here I'm changing the very same line in 2 different branches. Is it clear what's going on here? So I'm dealing with the very same line and I'm changing it in 2 different branches. And let me commit again, and let me commit let me say number 3. So here we are. Now, let's assume that I conclude my new feature, and I want my new feature changes. I want to merge back the new feature on the current branch. Okay. So I finish my work on the new feature branch. I want to merge back everything, all the codes in my master branch. So we already saw how to do it. This can be done by merge. Git merge and new feature. So in the previous example, we merge the master branch to the new feature branch. Now we are merging what is present in the new feature into the master branch. Okay, let's try to do it. Something different. What's going on here? Well, the auto merging feature of Git understood that actually there is a conflict in the main file. So in both the branches we have changed exactly the same line. So which one is the correct one? Git is not able to understand which of the 2 is intended to end up in the main, in the master branch. So it's warning you that, look, there is a conflict in the main file. I don't know which of the 2 versions is the correct one for your intention. Okay? So So have a look at the source right now. So reload. Here we have the source. The source is strange. I mean, we have something weird occurring here. Well, this part and the last part of the code works perfectly, but there is something wrong with this. Here, Git is telling you, look, this part of the code, so from here to here, excluded, these lines are the one in the master. Why in the master? Because the head is the current branch, let's say. Okay, is the last commit of the current branch. While these lines are included in the new feature branch, and this can be seen by looking at this line. So you have to decide whether use this one or this one. And it's up to you to fix this conflict, because Git is not able to understand what's going on here, of course. So how can we solve it? Well, let's say that we want to take the first line and the last line. First line in the head and the last line in the branch new feature. So we change the code, have a look at the status. Let's have a look at the status of our Git. This is it. Look, fix conflict and run Git commit. So the status is telling you, you are in the middle of the merge process. You haven't completed yet. You have to commit it. So once you have fixed every possible conflict in your code, you have to commit it. So let's try to commit it. Git commit. Again, here I can provide a message, or if I don't provide a message, I end up, okay, it's telling me since you change main, you have to add Okay, I was saying we ran out of time, and there are many other things that I want to tell you about Git. However, you may find some of them on the slides. So please have a look at them, because I assure you this is probably the most important tool you will use during your time in this program, and probably also outside this program, but during your work experiences. So that's all. So thank you for the attention. It was a pleasure to have you for this course. Again, if you have any questions, feel free to send me an email. Don't worry, I will be available for you even during the remaining 2 years of your life. Okay. Okay, thank you so much, and bye.